name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Networks. Today I am discussing about control memory. So, in the control memory, the major functional parts in a digital computer are central processing unit CPU, memory, and input-output devices. The main digital hardware functional units of CPU are control unit, arithmetic and logic unit, and registers. The function of the control unit in a digital computer is to initiate the sequence of micro operations and to generate the timing and the control signals. The complexity of the digital system is derived from the number of sequence of micro operations that are performed. Methods of implementing control unit are hardwired control unit, microprogrammed control unit. So, in the control memory, how we are controlling the memory in the CPU. So, in the CPU, CPU is a major role in the working this one. So, what are the parts are there in the CPU, memory, and input-output unit. So, how we are controlling this one. So, the major functional parts of the digital computer are central processing unit, CPU, memory, input-output. So, these are the major role to perform the programming. So, in these three operations, how we are controlling, that is the important thing. So, how we are controlling, what is the process for controlling, we will discuss. The main digital hardware functional units of CPU are control unit, arithmetic and logic unit, and registers. So, control unit, memory unit, and ALU means arithmetic logic unit. So, the main hardware functional units are CPU it is about the CPU. In the CPU, arithmetic logic unit, control unit, and memory unit is there. So, control unit means how we are controlling the arithmetic logic unit and memory unit between the input and output peripherals. So, control unit and arithmetic logic unit are the registers. The function of control unit in a digital computer is to initiate sequence of micro operations and to generate timing and control signals. So, how we are controlling means in the limited time period to generate the timing signals between the arithmetic logic unit and memory unit and input output units. Suppose I have to execute a program. How we are executing means, is it any help of ALU? No. First CPU will taking the program. Memory unit means which is it belongs to any of the memory? Is it belongs to input output or not? So all should be interconnected with generating the timing and control signals. The complexity of the digital system is derived from the number of sequence of micro operations that are performed. The methods of implementing control unit. So how we are implementing, how we are controlling, how we are process the control unit means two methods are there. Hardwired control unit, microprogrammed control unit. So it is a block diagram of control memory. First one, input device and output device. So already we discussed it between the input output I/O device. So in the I/O device, in between the input and output device, the input is connected to the CPU. It is the CPU. So in the CPU, what are that means? CPU means central processing unit. So in the central processing unit, what are the peripherals? What are the sub units are there? First one is a control unit, CU, arithmetic logic unit, ALU, and memory unit, MU. So CU, ALU, and MU. So these are the under the CPU. So it is the input and it is the output. So in between the input and output, what is the process? Central processing unit, control unit, arithmetic logic unit, and memory unit. Suppose if I need any arithmetic logic unit help, then the input is connected to the ALU, input output arithmetic logic unit, then it is connected to the memory unit. Why? Because if you want to perform any arithmetic or logic operations, the memory unit is needed to perform the operation. So control unit will controlling all the arithmetic logic unit, memory unit, and input output operations. So these are controlling. So controlling memory is a major role in between the input and output. So what is the input and output? What is the process is going on between the input output means control unit, arithmetic logic unit and memory unit. So these are under CPU. Okay. So between the input and output, what is there means CPU is there. Input, output, and CPU. In the CPU, three CU, MU, and ALU, like this. Okay. So input, CPU, and I'm taking output. So what are the subunits are there in the CPU means control unit, arithmetic logic unit, and memory unit. So in this arithmetic logic unit, these are the interconnections between the ALU and MU. So control unit will controlling input operations and output operations between the CPU. Okay, memory is connected or not, and arithmetic logic unit is need or not between the input output. So control unit will monitor all those things. So the methods of implementing control unit are hardwired control unit. It is the first method to implement in the control unit. So hardwired control unit means when the control signals are generated by hardware or logic gates, flip-flops, decoders, encoders, and finite state machines, etc. using conventional logic design techniques. So the involves use of fixed instructions, fixed logic blocks of and or arrays, encoders, decoders, etc. And what are the key characteristics? High speed operation, expensive, relatively complex, and no flexibility of addressing new instructions. What are the examples of hardwired control unit? Intel 8085, Motorola 6802, Geelong Z80, and any type of RISC CPU operations. So how we are operating hardwired control unit in the CPU? First one is the control signals are generated by the hardwired. So what are the control unit means? Logic gates. Already we know that now. What are the logic gates? And, or, not, NAND, NOR. These are the logic gates. And flip-flops. What is the use of flip-flop? One bit of information. So binary 1 or binary 0. Binary 0 or 1 will store. So flip-flop means 1 bit of storage. Only 1 bit of storage. Suppose I want to store 8 bit, means I need a 8 flip-flops or register. Set of flip-flops are called register. So 8 bit means 10 10 11 10 11 10 10. How many are there? 8 bits are there. So it is a register. So set of flip-flops are called register. Only 1 bit of information will be stored. That is called flip-flop. So already we know that decoder and encoder. So decoder means input. How many we are giving the inputs? It will be decoding and encoding and finite state machines, FSM, etc. using conventional logic design techniques. So these are the logic gates, flip-flops, decoders, encoders, and finite state machines are under control signals. These are generated by the hardware. So these are the logic gates, ICs, integrated circuits. So these are belongs to hardware. So what are the hardware involvement of CPU? What are the hardware involvement of arithmetic logic units? That is called hardwired control unit. So software also there. We will discuss next. So what are the hardwired means? Hardware means ICs. ICs involvement are there. Logic gates, flip-flops, decoder, encoder, and finite state machine, etc. And involves uses of fixed instructions, fixed logic blocks of and or arrays, encoders, decoders, or etc. are the hardware control unit. These are all belongs to integrated circuits. And what are the key characteristics? These are the high-speed operations, expensive, relatively complex, and no flexibility of addressing new instructions. So suppose I'm using these logic gates or flip-flops or decoder or encoder or FSMs. So what is the advantage? Especially I'm taking these all those things hardwares in the CPU, in the computer. What are the advantages? Means that is called key characteristics. Means like this, when I'm using logic gates, when I'm using decoder, encoder, it will nothing but these are the high-speed operation ICs, and these are expensive maybe and relatively complex, and no flexibility of addressing new instructions. So these are the advantages. And what are the examples of CPU? Intel 8085 and Motorola 6802, Geelong Z80, and any RISC CPUs are the examples of CPU. CPU means central processing unit. So it is a control unit of a basic computer system. So in the basic computer system, how the control unit is monitored? Here, instruction register IR. IR is taking 0 to 11 means it is a 12-bit information. 0 to 11 means 12. So 12, 13, 14, 15. That means total 16. Total 16 bits. 0 to 11 means 12 bits are there. 12, 13, 14, 15. So how many are there? These three are the 3 into 8 decoder. So what is a 3 into 8 decoder? Means 3 means I am taking as a 2 cube. 3 means 2 cube. What is the value of 2 cube? 8. So it is a 8. So input is 3, output is 8. 3 into 8. How we are getting 8 means 2 cube. So 3 into 8. So 3 are the inputs and 8 is the output. So 3 by 8 means 3 input and 8 output decoders. So it is an instruction register. So 12, 13, 14, 15 are there. Here also, suppose 0 is connected to D0 like this. D0, D0, D1, D2, D3, D4, D6 and 7 is connected to D7. And what are the timings are there? 4 into 6. Already we know that 4 into means 2 power 4 equal to 16. That means 4 equal to input, 16 is the output. So 4 input lines, 16 output lines. You can see here 4 input lines and 1, 2, so on, 16 output lines are there. So it is a 4 into 16 decoder, 4 input and 16 output. Here 3 into 8 means 3 input, 8 output. So how many 8 outputs are means D0 to D7. How many inputs are there means 3, 12th, 13th and 14th line and 14th pin. Here 4-bit sequence counter. 4-bit means 2 power 4. 4 input, 2 power 4 means 16 output. 4 into 16. So it is internally connected clock pulse, clear and increment INR. These are connected to 4-bit sequence counter and 16-bit means T0 to T15. T0 to T15 means how many are there? Total 16 pins. So total 16 means 4 into 16. 16 are connected. These 16 are connected to pins. So these D0 to D7, this 8 and this 16. So D0 to D7 is a 8-bit and 16 means T0 to T15. Total are connected to control logic gates. These are connected to control logic gates. So it is a control output. So control logic gates are connected to control outputs. And what are the other inputs are there? If any other inputs are there, it will be connected to this one. So how we are generating, how we are, the basic computer is connected to the control unit means 4-bit sequence counter is connected. That means 4 into 16. So 16 output pins, that is T0 to T15, total 16. And here 3 into 8 decoder means D0 to D7. So total 8. So 0 to 11 and 12, 13, 14 are the input and 15 are the instruction bit. So it is a control logic gate connected and output is a control output and other inputs are there. If available, it will be connected to control logic gate. So it is a basic computer of control unit. And the methods of implementing control unit are microprogrammed control unit. The principle of microprogramming is an elegant and systematic method for controlling the micro operation sequences in a digital computer. So the microprogramming is a method of designing control unit in which the control signal selection and the sequencing information is stored in a ROM or RAM called control memory, and a sequence of micro instructions designed to control a specific instruction is called a microprogramming. And these are the examples of CPU. So what are the example means Intel 8080, Motorola 68000 and any CISC CPU are there. These are the microprogramming control unit. So in the control unit, total 2 methods are there. First one is a hardwired. Second one is a microprogrammed. Microprogrammed control unit. So microprogrammed control unit means micro operations. It is completely belongs to software. In the previous method, hardwired means hardware instructions. Here microprogramming means software programming related unit. That is a microprogrammed control unit. So the principle of microprogramming is an elegant and systematic method of controlling the micro operation sequences in a digital computer. So the microprogramming is a method of designing a control unit in which control signal selections and the sequence of information is stored in a ROM or RAM is called control memory. So already we know that ROM means it is a memory and RAM is it for the temporary operations. For the temporary operations we are using this one. So ROM means permanent memory. So which memory you have to select, you can select and you can execute this one. That is a microprogramming. And the sequence of micro instructions are designed to control a specific instructions are called microprogramming. Suppose instruction specific program. Suppose I have to give some specific instructions to the computer. Then only I have to execute. That is called microprogramming. So the examples of CPUs are Intel 8080, Motorola 68000 and CISC CPU operations. These are the microprogramming operations. And how the methods of implementing control unit are in the microprogramming control are, for each micro operation controlling unit has to generate a set of control signals. For any micro operation of control line may be on or off, which can be represented by a binary pattern. Thus, a control board is constructed for each micro operation. A computer that employs a microprogrammer control unit will have two separate memories, a main memory and a control memory. So, in the previous microprogramming, what we discussed, what is a microprogramming and how we are executing the microprogramming and what are the examples of microprogramming discussed in this slide. Here, the another some abbreviations are there in the microprogramming are there. The micro operations control unit has to generate a set of control signals. So we have to generate control signals from input to output. And for any micro operations, any control line may be on or off, which can be represented by a binary pattern. Thus, a control board is constructed for each micro operation. A computer that employs a microprogrammer control unit will have two separate memories, main memory and control memory. In the previously we discussed ROM and ROM only, but here we are taking main memory or control memory. We have to approach these two types of memories for microprogramming operations. And the programs are usually stored in the main memory by the users. Whenever the programs change, the data is also modified in the main memory. The consist of machine instructions and data. The control memory consists of microprogramming that are fixed and cannot be modified frequently. The contain micro operations that specify the internal control signals required to execute registers of micro operations. The machine instruction generate a chain of micro operations in the control unit. Their function is to generate micro operations that can fetch instructions from the main memory, compute the effective address, execute the operation, and return of control fetch phase and continue the cycle. So, I am taking the control unit with the machine instruction data. Machine instruction data. So, in the machine instruction data, the stored of the data in the main memory, whenever the programs are changed, the data is also modified. So, when the data will be changed, then we have to storing the data of the memory. We have to change. These type of related things are called machine instructions and data. So, the control memory consists of microprograms that are fixed and cannot be modified frequently. They contain micro instructions that specify the internal control signals required to execute register of micro operations. So, like these micro operations, we have to go for the instructions. We have to follow the instructions. Those instructions I am calling as a micro instructions that specify the internal control signals to require the executing the register of micro operations. And the machine instruction is nothing but to generate a chain of instructions in the control memory. Their function is to generate micro operations that can fetch instructions from the main memory and to compute the effective address, execute the operation and return the control fetch phase and continue the cycle. So these are all called control memory. And it is another block diagram and another way of control unit. It is a microprogrammer control organization and it is a external input control word. Input is the external input connected. External means another device is connected to this one. So external input is connected to first phase. What is the first phase? Next address generator. That is the sequencer. After then control address. That is called register. Another one is a control memory or ROM. Control data register. That is called next address information. So next address generator means sequencer. Means we have to giving the information to the next value. That is a control address register. Control means it is controlling all the input data to transfer to the related memory, RAM or ROM. Here I'm transferring to the ROM. Okay. In this ROM, it is a ROM with the control memory. It is transferred to control data register. Control data register means shall we get the any output to this one? Control one? Yes, we have to get. Otherwise, we have to store the data and we have to wait for another data and we have to attach or we have to transfer the data to the another one. That is a control word. It is the next address information. Next address means this data is completed. So I'm waiting for next address. So next address information. Here, the control memory is assumed to be a read-only memory. There will be a control information is stored permanently. ROM provides the address of the micro instruction. The other registers, that is the control data register, stores the micro instruction that is read from the memory, and it is consist of a control word that holds one or more micro operations for the data processor. So, already we discussed in the control memory, it is a two types, RAM and ROM memory. So, which memory we have to use? If I'm taking the ROM, it is the control information is stored permanently with the ROM. Temporarily means I'm going for the RAM. So the other register is the control data register to store some micro instructions, and that is read from the memory, and it is consist of a control word that holds one or more micro operations for the data processor. Not only one word, more data is there. So multiple words, control word that holds the one or more micro operations. Not only single operation, multiple more micro operations are there. We have to still waiting for that one. And the next address must be computed once this operation is completed, and it is computed in the next address generator, and it is sent to the control address register to be read. And the next address register is also known as the microprogramming sequencer. Based on the inputs to a sequencer, it determines the address of the next micro instruction. The micro instructions can be specified in several ways. So what are the ways means? The main function of microprogramming sequences are, it can be increment the control register, and it can load the address from the control memory and to control address register, and it can transfer an external address or load to initial address to begin the start operation. So it is a one thing of this one. So how we are controlling the memory in the next address register? It must be computed once this operation is completed, and it is computed in the next address generator. Then it is sent to the control address register to be read. So the next address generator is known as a micro program sequencer, and based on this input sequencer, it determines the address of the next instruction. Suppose one instruction is completed, I'm going for the next instruction. So what is the current instruction? What is the next instruction? So what is the address of the current? What is the address of the next instruction? So these we know. Address of the next instruction. The micro operations can be specified in several ways. The main functions of a microprogramming sequencer are, it can be increment the control register by 1. So what are the values are there in the control register? We have to increment by 1, and it can be load the address from the control memory to the control register, and it can transfer an external address or load an initial address to begin the start operation. Okay, these are the main functions of a micro sequencer. And the data register is also known as a pipeline register. It allows two operations to be performed at a time, and it allows performing the micro operations specified by the control word, and also the generation of the next micro operations. And a dual phase clock is required to be applied to the address register and the data register, and it is possible to apply the single phase clock to the address register and work without the control register. And the main advantage of using a microprogramming control is that if the hardware configuration is established once, no further changes can be done. However, if a difference of control sequence is to be implemented, a new set of micro operations for the system must be developed. So the data register is also known as a pipeline register. So pipeline means one by one operations to be performed. So the pipeline register allows to the operations to be performed at a time, and it allows to performing the micro operations specified by the control board and also to the generation of the next micro instruction. And a dual phase clock means already we know that now every generation of character or instruction, it is a next instruction. So dual phase clock is required to be applied to the address of the register and the data register. It is possible to apply a single phase clock to the address register and work without the control data register. So the main advantage of using a microprogrammed control is that if the hardware configuration is established once, no further changes can be done. However, if a different control sequence is to be implemented, a new set of micro operations for the system must be developed. So a dual phase clock for the input. Suppose I am taking the input and output operations. A dual clock pulse is important to requiring the micro operations of the address register and the data register. And it is possible to apply a single phase clock to the address register and work without the control data register. And what are the main advantages of using the microprogramming is that the hardware configuration is established once, no further changes, and can be done. However, if a different control sequence is to be implemented and a new set of micro instructions for the system must be developed. So it is a difference of hardwired control and microprogrammed control unit. So what is the first one means? Hardwired control unit generates the control signals needed for the processor using logic circuits, and the microprogramming control unit is nothing but the unit of generator of the control signal with the help of micro instructions stored in a control memory. And the hardware control unit is faster when to comparing to the microprogramming control unit, as required to control signals are generated with the help of hardware, and this is the slower of the other micro operations used in generating the signals here. So the difficulties to modify as a control signals that need to be generated are hardwired, easy to modify as the modification need to be done only at the instruction level, and more costlier as everything has to be realized in terms of logic gates, and less costlier than hardware control as only micro instructions is used for generating of control signals, and it cannot be handle complex instructions as the circuit design for it becomes complex, and it can handle complex instructions. When I'm going for the hardwired control unit, it only limited number of instructions are used due to the hardwired implementation. When I'm going for the microprogramming operation, the control signals for many instructions can be generated. When I'm going for the hardwired control unit, it is the computer that makes use of reduced instruction set risk. When I'm using for the microprogramming, it is the RISC and CISC. When I'm going for the RISC and CISC operations, it is a hardwired control unit and it is a microprogrammed control unit. So it is a major difference of hardwired control unit and microprogrammed control unit. So today we discussed what is the control memory and what are the types of control memories are there. So in the control memory, what are the major parts are there means CPU, memory and input output unit, and the mini digital hardware functions are control unit, arithmetic logic unit and registers. And the function of the control unit are the digital computer to initiate the sequence of micro operations, to generate the timings and the control signals, and the complexity of the digital system is derived from the number of sequences of micro operations. So what are the major types of control units are there? Hardwired control unit, microprogrammed control unit. Hardwired means it is belongs to hardware, and microprogramming means it is belongs to software. So the combination of hardware and software is nothing but a micro operations of implementation of control unit. So it is a block diagram of control unit, control memory. In the control memory, what are the types are there means it is a CPU. In the CPU, control unit, arithmetic or logic unit and memory unit. These are the subtypes of CPU, and input and outputs are there. Input is connected to CPU, and from CPU to output will be there. So input and output are the peripheral devices. So first I am giving the signal to the input device, then it is passed to the control unit. So control unit will check is it arithmetic logic unit or not. If it is arithmetic logic unit, then it is connected to arithmetic logic unit. If not means, if directly it is connected to memory unit, and it will be executed a program directly to the output device. And what are the hardwired control unit? Hardwire means it is completely hardware. Means ICs, integrated circuits, are inbuilt to the computer. That is hardware. Logic gates, flip-flops, decoders, encoders, and finite state machines. These are the hardware control units. And it is the involvement of fixed instructions and fixed logic blocks and our arrays, encoders, decoders. These are under hardwired control unit. And what are the key characteristics? When I'm using these hardware control units like logic gates, flip-flops, finite state machines, decoders, encoders, that is a high-speed operations, expensive, relatively complex, and no flexibility of addressing of new instructions. When I'm going for the example of CPU, so what are the examples of hardware? Means Intel 8085, Motorola 6802, Zilog Z80, and any RISC CPU operations. And it is the basic computer with control unit. So here 0 to 15, total 16 instruction registers are there. 0 to 11 are connected to control logic gate. So 12, 13, 14 are the input pins are connected to decoder. So how many are there? 3. 3 inputs means 2 cubed. 2 power 3 equal to 8 output lines are there. So what are the input means? 12, 13, 14 are connected to input lines of decoder. And what are the 8 output lines are means D0 to D7. So another 4 into 6 decoder is connected to the control logic gate, that is 4 into 16. So 4 input lines and 16 output lines. 4 means 2 power 4 equal to 16 output lines. So decoder is nothing but a 4 into 16 means 2 power 4 into 16. 2 power 4 equal means 16. So 4 input and 16 output lines are there. So it is a 4-bit sequence counter is connected to the input of 4 into 8 decoder. And what are the output means? 16 output lines are there. That is T0 to T15. So one decoder of 8 lines are connected to control logic D0 to D7, and another decoder 16 lines are connected to T0 to T15 is a control logic gates. So total 16 plus 8. So total 24 are connected to control logic gates, and these control logic gates are the final output of control outputs. And if any other inputs are there, these are also connected to control logic gates. And it is a microprogrammed control unit. Microprogramming means it is like a software. So we are giving some instructions to the CPU. Then it will be execute. We need a memory. Yes, we need a memory like a RAM and ROM. And for micro operations, the control unit has to generate the control signals. For micro operations, control line may be on off, which can be represented by a binary pattern. A computer that applies microprogrammed control unit, which have to separate two memories, that is a main memory and control memory. So when I'm using the main memory of the user, the programs change, the data will be modified from the main memory. That is called the machine instruction of the data. So that data will be changed, the memory also will be changed. Like this, we are calling as a micro instructions of the data. And it is another way of control unit or microprogramming control memory. The external input is connected to next address generator, that is a sequencer. This sequence is connected to the control address register. Means it is control address means control memory. So how many bits we are connected? 8-bit or 16-bit or both. And the control memory means we have to take RAM or ROM. But here mostly we are taking ROM for memory, means for permanent storage of the memory. So control data register means we are controlling all the data through the signals. So that is a control word. Next address information means after completion of this data, next data will be going to the external input to the next address generator. That is the next address information. And here read-only memory and read-only memory is a permanent information. The control information is stored permanently, and the other register is a control data register stored in the micro instructions in the read from the memory. It consists of control word that holds one or more micro operations for the data processor. And the main functions of a microprogram is to increment the control register by 1, the load addressing of that, transfer the external. So first incrementing, loading, and transfer. So these are the main functions of a microprogramming sequencer. So another one is a pipeline register. It allows two operations to perform in a time, and it allows performing the micro operations specified by the control word. And the dual phase clock also required to microprogramming operations. And these are the major differences of hardwired control unit and microprogrammed control unit. And what are the major means? RISC and CISC operations will be performed. The computer that makes RISC operation, that is a hardware. The computer that makes CISC operation, that is a microprogrammable control unit. These are the about the control memory. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.